I'm Arpita Shome, Assistant Professor of Information Technology of Haldia Institute of Technology. Today my topic is disk scheduling algorithms. So what is disk scheduling? It is basically done by operating systems to schedule I/O requests arriving for the disk. It is also known as I/O scheduling. Basically, it is a technique to maintain the order in which the I/O request is handled or processed by the disk. It is basically the main goal of disk scheduling is basically to reduce the time that is taken to the disk for processing the scheduling or processing the request. So first we need to know the hard disk architecture. In this hard disk architecture there are multiple platters, that is these are the platters. The platters are divided into multiple tracks. These circular lines are tracks and the tracks are divided into multiple sectors. Okay, this is the spindle and this is the arm assembly or actuator arm. The rotation is from the right to left. Basically, in every platter there are two surfaces, lower surface and upper surface, and in every platter there are read and write heads. Okay, that is, in every platter there are read and write heads. Suppose we want to access a particular sector. Whenever a user wants to save some data into the memory, the operating system basically saves the data or stores the data into these sectors. Or particularly suppose we want to access some data. Suppose this position is 50. We want to access the data in the position of 80. So the read and write have to move to the position 80. Okay. So this is the total seek time. Basically the time required to locate to the desired track. Next, what is the importance of disk scheduling? That is, multiple I/O requests may arrive by different processes, but only one I/O request can serve at a time by the disk controller. Thus, the I/O requests need to wait in the waiting queue and need to be scheduled. Two or more requests may be far from each other, so this can result in great disk arm movement. Hard drives are one of the slowest parts of the computer system that needs to be accessed in an efficient manner. There are suppose some of the key terms associated with disk scheduling, that is seek time. The time is taken to locate the disk arm to a specified track where the data is to be read or written. So which gives minimum average seek time is better. Next is rotational latency. It is the time taken by the desired particular sector of the disk to rotate into a position so that it can access the read and write heads. So the disk scheduler algorithm that gives minimum rotational latency is basically better. What is the transfer time? It is basically depends on the rotation speed, the time to transfer the data, the number of bits that is to be transferred. The key terms associated with disk scheduling are disk access time and disk response time. Disk access time is basically seek time plus rotational latency plus transfer time. Total seek time is basically total head movement into seek time. What is the disk response time? The response time is the average time spent by a request waiting to perform its I/O operation. The response time of all requests is basically the average response time. Variance response time is the measure of how individual requests are serviced with respect to average response time. So basically disk access time is seek time plus rotational latency plus transfer time, and disk response time is disk queuing, DLA queuing plus seek time plus rotational latency plus transfer time. Okay, these are some of the key terms. Next, disk scheduling algorithm. There are six main of the disk scheduling algorithms: first come first served, shortest seek time first, elevator algorithm, circular scan, look, and circular look. First is first come first served. It is the simplest of all. Here the requests are addressed in order they arrive in the disk queue. Okay. First we want to take an example. So order of request will be 82, 170, 43, 140, 24, 16 and 190. Current position is 50. So the disk movement will be from 50 to 80. Then 80 to 170, 170 to 43, 43 to 140, 140 to 24, 24 to 16 and 16 to 199, 190. So the total overhead movement will be total distance covered by the disk arm. That is, first we moved from position 50 to 80. That is, basically there is no negative. So we are basically subtracting from the bigger value. That is from 80 to 80 minus 50, 170 minus 82, 170 minus 43, 140 minus 43. That is, we are going from 140 to 43, then from 24. So 140 minus 43 plus 140 minus 24. Okay. Then 24 minus 16 and last 190 minus 16. So total will be 642. These are the movements from 50 to 82, 82 to 170, 170 to 43. Then 43 from again from 43, 140, 140 to 24, 24 to 16 and 16 from 190. Okay. Next, what are the advantages and disadvantages of FCFS? Some of the advantages are every request gets a fair chance and no indefinite postponement. Disadvantages are doesn't try to optimize seek time and may not provide the best possible service. Next, shortest seek time first. In shortest seek time first, requests having the shortest seek time are executed first. So the seek time of every request is calculated in advance in the queue. Then they are scheduled according to their calculated seek time. As a result, the request near the disk arm will execute it first. SSTF is certainly an improvement over FCFS as it decreases the average response time and increases the throughput of the system. Then let us take an example. Current position in 50 and the request is same. So total overhead movement will be, first we are calculating the seek time. So from 50, which is the nearest, that is 43. So we are basically first going to 43. Okay. So 50 minus 43. We are calculating the distance. Then which is the shortest or nearest, that is 24 after 43. After 24, that is 16. Okay. And after 16, from rest of the request, that is 82. From 82, the nearest is 140. From 140, the nearest is 170. And from 170, the nearest is 190. So the total calculation will be 208. Okay. This saw the diagram. That is, we are basically calculating using the shortest seek time. Okay. Basically, the shortest distance. So from 50, we are going to 43, then 24, then 16. Then the nearest will be 82, then 140, 170, and the last one is 190. Next algorithm is our. So first, let us talk about the advantage and disadvantage of SSTF. Throughput increases and disadvantage is overhead to calculate seek time in advance. We have to calculate the seek time in advance. Can cause starvation for a request if it has higher seek time as compared to incoming request, and the high variance of response time as SSTF favors only some requests that are nearest. Next algorithm is scan algorithm or elevator. In the scan algorithm, the disk arm moves in a particular direction that can be from larger direction or a smaller direction and services the request coming in its path. After reaching the end of the disk, it reverses its direction and again services the request arriving in its path. So this algorithm works as an elevator, and it enhances also known as an elevator algorithm. As a result, the requests at the mid-range are serviced more and those arriving behind the disk arm will have to wait. Same example, but we have to move towards the larger value. Okay, the disk current position is 50. As we know, we are moving to the larger direction. What is the larger of 50? From 50 we are first going to 82, then 140, then 170, then 190. Okay, so 190 is the last position, but our total disk size is 200, so that is from 0 to 199. So we have to reach the end of the disk. Okay, so end is 199. So from position 50 we have to strictly go to 199. So for that 199 minus 50, that will be total distance first. Then from 199 we have to again go to the position 16 through 43, 24 and 16. So the last position is 16. So 199 minus 16. So total will be 332. 332. This is the total diagram. First from 50, we are going to the larger, towards the larger value 82, 140, 170, 190 and the end is 199. From 199 we are again going to the smaller side. Okay, that is 43, 24 and the last one is 16. Okay. Advantages of and disadvantages of scan algorithm. Advantages are high throughput, low variance of response time, average response time. Disadvantages of scan algorithm: long waiting time for requests for location just visited by DIXAM. Next is look algorithm. Look algorithm is basically similar to the scan disk scheduling algorithm, except for the difference that the disk arm, in spite of going to the end of the disk, goes only to the last request to be serviced in front of the head, and then it reverses its direction from there on. Thus, it prevents the extra delay which occurred due to unnecessary traversal to the end of the disk. So same example, and we are going to towards the larger value. So both are the actually same, scan and look, but what is the difference? In spite of going to the end of the disk, goes only to the last request to be serviced in front of the head and then reverse. So what is our last request? Last, that is we are going towards the larger value. The last request is 190. So we are going from the current position, that is from 50, we are going to the last request to 190. So 190 minus 50 is the first step. Then from 190 position to 43, 24, we are going to the smallest position or smallest request, that is smallest value, that is 16. That is we have to calculate the distance also, that is 190 minus 16. So total will be 340. Let's look at the diagram. We are going from 50 to 82, then 140, 170, 190. From 190 we are going to 43, 24 and 16. Okay. Our next algorithm is C-scan, okay, or circular scan. In the scan algorithm, the digsum again scans the path that has been scanned after reversing its direction. So it may be possible that too many requests are waiting at the other end, or there may be zero or few requests pending at the basically scanned area. These situations are avoided in the scan algorithm, in which the digsum, instead of reversing its direction, goes to the other end of the disk and starts servicing the request from there. So the digsum moves in a circular motion. Okay. So this is the same request, and the value, basically the arm movement will be towards the larger value. And so the total overhead movement, basically the distance, as we know, as per the scan algorithm, C-scan is, first we are going from the particular current position to the last position, that is towards the larger value. Then from the larger value we are going to the first position, the end of the other position, that may be also 0. Here in our condition, that is 0. So we are going from 199 to 0, and then from 0 we are again start moving towards the other values. Okay, that is, we are basically going from the current 50 position to the last larger position, that is 199. So 199 minus 50. Then from 199 we are going to the other end, that is 0. So 199 minus 0. Then from 0 we are going to the other request, that is smaller of 50, that is 43. So we are going from the position 0 to the 43 through 1624. Okay. What is the advantages of C-scan algorithm? That is, it provides more uniform wait time compared to scan. Let's look at the diagram. Circular scan. From 50 we are going to position 80, then 140, 170, 190, and the last position is 199. From 199 we are going to the other end position, that is in our case 0, and again from 0 we are starting moving the arm, that is from 0 we are going to 16, 24, and the last request is 43. These are total movement. Our last algorithm is C loop. As loop is similar to a scan algorithm, in a similar way, C loop is similar to the C-scan scheduling algorithm. In C loop, the digsum, in spite of going to the end, goes only to the last request to be serviced in front of the head, and then from there goes to the other end's last request. Thus, it also prevents the extra delay which occurred due to unnecessary traversal to the end of the disk. Here we are taking same example. These are our requests: 82, 170, 43, 140, 24, 16, and 190. And the read-write arm, that is current position, is 50. And it is also given that the disk arm should move towards the larger value. So our total overhead movement, all the total disk distance covered by the disk arm will be, as per our current position is 50, but we are going towards the larger value. So our last highest request is 190. So from current position 50, we are going to the last request, that is 190. Okay. Then from 190, we are going to the other end, that is in our case 0. So from not going to the other end, the last small request of the other end, that is in our case, what is the smallest request on the other end? That is 16. So the last request to be serviced in front of the head, and then from there it goes the other end's last request. So from we are going to 190 to other end's last request, that is 16. So from 50, first we are going to the position 190 through 82, 140 and 170. Then we're going towards the larger value 190. From 190 we are going to the other end's last request, that is 16, and from the 16 value we move towards the other request, that is towards 43 through 24. So the movement will be from 50 we are going to 190, so 190 minus 50. From 190 we are going to the value of 16. Okay, the other ends last request. So 190 minus 16, and from 16 we are going to the towards the other request, that is 43. So plus 43 minus 16. So the total distance covered by the disk arm will be 341. So these are the algorithms. So this is the diagram of C loop. From 50 we are going to 82. From 82 we are going to 140. Then from 140 to 170, then 190. From 190 we are going to the other end's last request, that is 16. Then from 16, 24, and 24 to 43. Okay. So these are the algorithms are basically used for disk scheduling. Thank you.